Hello everyone, good evening. So in this lecture I am going to explain the following topic: AC through resistor, AC through pure inductor, AC through pure capacitor, AC through RL circuit, AC through RC circuit, and finally AC through RLC circuit. So we'll be discussing in detail if AC supply is given to pure resistor, pure inductor, pure capacitor, then what about its opposition like resistance, inductive reactance and capacitance? What about its power factor? Then we'll talk about if AC supply is given to RL circuit and RC circuit, what about its impedance? Impedance का expression क्या है? What about its power factor? How much power that circuit will consume? And finally, we'll discuss if AC supply is given to RLC series circuit, then what about its power factor? What is the impedance formula? How current can be calculated? And we'll solve some numerical based on this concept. So without further delay, we'll start the session. My name is SRP. You are watching my beautiful channel, Love You Science. So let's start. So first is AC through pure resistor. AC through resistor. Okay. Let this one is your resistor and AC supply is given to resistor. As you know, that is symbol of AC supply. What is the instantaneous equation of AC supply? That is Vm sin omega t or Vm sin theta. Then current क्या होगा देखो, current through this circuit will be, as you know, according, so in place of V I can write here Vm sin omega t, and this one is R. See, maximum voltage is constant, so maximum voltage upon current will be maximum, sorry, maximum voltage upon resistance will be maximum current. So that means I will be Im sin omega t. Clear? So what you conclude from here? Here we have given supply voltage as Vm sin omega t and we are getting current as sin omega t. If I compare voltage to current, what about its angle difference? What is the phase difference between these two quantities? See, in voltage, what is the phase? Omega t. Phase matlab angle. Angle is omega t. So in case of current, what is angle or phase? Phase is omega t. What is the phase difference? 0. Matlab I can write down here phase difference का symbol phi होता है. Phase difference will be 0. Phase difference matlab the angle difference between voltage and current. Again I repeat, the phase of voltage is omega t, phase of current is omega t. What is the phase difference? Phase difference is 0. And AC में पावर का फॉर्मूला क्या होता है? DC में पावर फॉर्मूला VI होता है, बट AC में VI cos phi होता है. Here cos phi क्या होता है? Cos phi power factor. So cos phi is power factor. So here cos 0 is 1, मतलब power factor is 1. So DC circuit is a unity power factor circuit. क्या है? Unity power factor circuit. Now what is final power consumption by this circuit? So it will be VI. So matlab if AC supply is given to pure resistor, it will consume this power as VI. Matlab that will act as DC circuit. So now if I compare between the voltage and current, we can draw the waveform. If I take omega t in x-axis and voltage and current in y-axis, let this one is graph of voltage, that is Vm sin omega t, and what is the nature of current? Nature of current will be same. This one is Im sin omega t. See, by comparing voltage and current, the phase difference will be 0. Let us consider this point. At this point, what is the phase of voltage? 90 degree. What is the phase of current? Again 90 degree. So what is the phase difference? It is 0. कोई भी instant you can take. You can take 0, you can take pi by 2 pi, 3 pi by 2, 2 pi. So every instant will be getting this 0 phase difference. मतलब angle difference between voltage and current will be 0. Difference क्या है? The maximum value will be different. That depends on the value of resistance. The maximum value here Im. This is Im. And maximum value of voltage is Vm. So Vm and that value of Vm and Im depends on the value of resistance. So ये हो गया waveform. मतलब by drawing that graph, we can compare the angle between voltage and current. But I am going to give a shortcut. That is phasor diagram method. Phasor diagram क्या है? मैंने जैसे लास्ट वीडियो में बोला था, phasor क्या होता है? It is a rotating vector. Simply याद रखो, phasor मतलब it's a rotating vector. So always, for easy understanding, you take current as your reference parameter, which will be in x-axis. Always remember. मतलब I have taken current in x-axis. So the voltage, so if I rotate the voltage, I'll be getting voltage in same axis since angle difference 0. Matlab from this diagram we can say the angle difference between voltage and current is 0. Matlab both the vectors are parallel to each other, maximum value may be difference, but both the vectors are in same direction. What is the angle difference between these two vector or two phasor? That is 0 degree. So ये जो diagram को हम लोग बोलते हैं phasor diagram. क्या है? Phasor diagram. So next onwards, while I am teaching AC through RL circuit or RC circuit, that diagram will help you to derive the expression of impedance. So we cannot draw the diagram. Okay. So by using this phasor diagram concept, we can derive the expression of impedance of RL circuit, RC circuit, RLC circuit. Okay. I hope it is clear. Okay. So now coming to next point, AC through pure inductor. AC through pure inductor. Matlab here there is a inductor having inductance L and we are providing AC supply. What is the instantaneous equation of AC supply? That is Vm sin omega t. And what I'm going to find out? The expression of current. That is our objective. Okay. So so to find out the expression of current, we need to understand what is the role of inductance. Inductor actually क्या होता है? It is an energy storing device which store energy in terms of magnetic field. Okay, and there is a property of inductance will oppose sudden change in current. एक कॉन्सेप्ट याद रखो, अगर आपके पास एक कॉइल है, कॉइल का इंडक्टेंस एल, इसका मतलब क्या होता है? जैसे क्लास 12th में था ना, इफ करंट इज फ्लोइंग थ्रू ए कॉइल, इफ करंट इज फ्लोइंग थ्रू ए सॉलिनॉइड और कॉइल, यू कैन से मैग्नेटिक फील्ड विल डेवलप. सो मैग्नेटिक फील्ड इनटू एरिया विल बी मैग्नेटिक फ्लक्स. मतलब फाई इज डायरेक्टली प्रोपोर्शनल टू आई. फाई क्या है? फ्लक्स. फाई क्या है? मैग्नेटिक फ्लक्स. मतलब मैग्नेटिक फ्लक्स इज डायरेक्टली प्रोपोर्शनल टू करंट. So phi will be equal to some proportionality constant into I. That proportionality constant is called inductance. But actually inductance is not constant. It can change with respect to dimension of that coil. If I change the length of the coil and change the area of the coil, inductance will change. That we know from the basics. So anyhow, inductance क्या है? Inductance is a proportionality constant, or you can say inductance is a property of a conductor which opposes sudden change in current. मतलब it will oppose di upon dt. Right? So you know, according to Faraday's law of electromagnetic induction, EMF is d phi upon dt. I'm taking its modulus, magnitude. Actually EMF is minus d phi upon dt. Minus symbol bhul jao, that will give the direction of induced current according to Lenz's law. Anyhow, so EMF is d phi upon dt. मतलब d by dt differentiation of phi क्या है इधर? What is the phi? Li. ठीक है. So L is constant, ये बाहर, तो L into di upon dt. ये याद रखो. मतलब whenever current is flowing through an inductor, EMF will be induced across the two terminals. That EMF is L into di upon dt. Actually it will be minus. ठीक है. मतलब EMF will be developed across the coil. That value is minus of L into di upon dt. EMF क्या होता है? Potential difference. EM almost same होता है. मतलब V will be L into di upon dt. So that means sorry. So that means whenever current is flowing through an inductor, so voltage will drop or EMF will be induced. That will be minus into L into di upon dt. Is it clear? So according to energy conservation, the amount of voltage which will be given from the supply side will be consumed here. Voltage क्या होता है? It is a potential difference that is work done upon charge. As per the work energy theorem, the amount of energy which will be getting from the supply will be consumed over here. So that means if I take the modulus of that VL, it will be L into di upon dt. So as per the energy conservation, this Vm sin omega t will be equal to L into di upon dt. Matlab I can write down here L into di upon dt will be equal to Vm sin omega t. That is as per the energy conservation. Okay, clear? Again I repeat, whenever current is flowing through an inductor, EMF will be developed according to Faraday's law. That EMF, let it be VL, voltage across inductor, which will be minus of L di upon dt. But here I have taken the modulus. Next, as per the energy conservation, the energy will be that energy which will be given, that inductor will be consumed by that inductor or LDI upon dt. Minus symbol is there according to Lenz's law, it will oppose the cause. The voltage which will be induced in the coil will oppose the cause. Cause matlab here Vm sin omega. That's why minus symbol was given. But anyhow, we take the modulus. मतलब दोनों को equate करो. L into di upon dt is Vm sin omega t. Then it is very easy. You have to integrate. Di क्या है? Vm sin omega t into dt upon L. Yes or no? If I want to find out I, then I have to integrate the current di. If I integrate this one, so matlab Vm by L into sin omega t into dt. So here I am writing I will be Vm by L is the constant, sin omega t into dt का integration क्या होता है? Tell me, sin omega t into dt का integration होता है minus of cos omega t, मतलब minus of cos omega t by omega, मतलब it will be Vm upon omega L. See, Vm by L is constant, Vm by L is constant. Sin omega t का integration minus cos omega t by omega. So I can write down minus cos omega t by omega. ठीक है? Understood? Now, so matlab you are getting the expression of current in terms of cos function, but we have given voltage in terms of sin function. So it is very difficult to compare. अगर एक फंक्शन साइन में एक फंक्शन कॉस में है, so we can compare, but it will take more time. So better we can convert that cos function to sin function. How? So I can write down here Vm by omega L in place of cos minus cos omega t. I can write down sin omega t minus of pi by 2. अरे sin theta minus 90 is minus cos theta. ठीक है? Understood? So let this part is Im, मतलब I is equal to Im sin omega t minus pi by 2. ये क्यों Im? देखो इसका लॉजिक देखो, Vm upon omega L. ठीक है? So I can write on Vm by some opposition. That opposition is called XL, inductive reactance, which is Im. So यहाँ लिखो Im क्या था? Vm upon omega L. एक नहीं, Im मतलब Vm upon omega L. Maximum current is maximum voltage upon omega L. According to Ohm's law, current क्या है? Voltage upon opposition. अरे DC में current होता है voltage by resistance, but AC में current होता है voltage upon any opposition. That opposition offered by this inductor is called XL, inductive reactance. क्या है? Inductive reactance. Important point याद रखो. What is the unit? Ohm. It is a kind of opposition. मतलब the opposition offered by this circuit is XL, which is omega L. That is omega क्या है? 2 pi f into L. याद रखो XL क्या है? XL is the inductive reactance. मतलब opposition offered by the inductor which oppose the flow of current. Yes or no? मतलब Im is Vm upon XL. So XL क्या है? Inductive reactance, which is omega L. ठीक है? So that means your voltage, applied voltage was Vm sin omega t, and current you are getting Im sin omega t minus pi by 2. So if I compare these two quantity, so the angle or the phase of voltage is omega t, but the phase of current is omega t minus pi by 2. Again I repeat, the angle of voltage or phase of voltage is omega t, and the angle or phase of current is omega t minus pi by 2. So what is the phase difference? Pi by 2. Yes or no? What is the phase difference? The phase difference is pi by 2. Phase difference क्या था? Phi. But now the point is leading or lagging. मतलब voltage is leading और current is leading, तो चेक करना पड़ेगा. ठीक है? So याद रखो एक चीज, phase difference is pi by 2, no doubt, it is okay, but whether it is leading or lagging, so to understand this one we can go for the phasor diagram. देखो phasor diagram से पहले wave diagram देखो. अगर ये आपको वोल्टेज है Vm sin omega t, करंट का इक्वेशन क्या है? Im sin omega t minus 90 डिग्री, मतलब आफ्टर 90 डिग्री करंट विल स्टार्ट. एक्चुअली इट इज अ कंटिन्यूअस थिंग, यू कैन स्टार्ट फ्रॉम दिस पॉइंट. So मतलब पहले वोल्टेज देन current. So it is Im sin omega t minus pi by 2 with respect to origin. So what is the phase difference? What is the phase difference? Pi by 2. कोई भी इंस्टेंट चेक करो, ये इंस्टेंट चेक करो, एंगल ऑफ वोल्टेज इज 180 degree of pi, angle of current is pi by 2, so pi minus pi by 2 is pi by 2. So at any instant you can check angle difference or phase difference will be pi by 2. So मतलब to know whether this circuit is leading or lagging, so check करो, if current is leading that is leading circuit, if current is lagging that is called lagging circuit. मतलब पहले voltage उसके बाद current, मतलब current lags pi by 2 with respect to voltage. And don't say it is leading circuit. If we take voltage as our reference point, we can say voltage lead current of angle pi by 2. But you cannot say both the thing. You cannot say voltage lead current lag. So for easy understanding, we can take current as our reference parameter. If current is leading, that is leading circuit. If current is lagging, that is called lagging circuit. See how to remember this one. मैं जो shortcut दिया था देखो phasor diagram. मैंने क्या बोला था? You take current as your reference parameter, which will be in x-axis. Always you take current as your reference parameter, which will be in x-axis. Then you move clockwise. If we move clockwise, first you will face voltage. First we will face voltage because voltage Vm sin omega t, current Im sin omega t minus 90 degree. मतलब after 90 degree, always you have to move clockwise. मतलब after 90 degree current will start. So by looking from the diagram, you can say current lags pi by 2. Is it clear? Now last point is very important. Power का formula क्या होता है? Vi cos phi. Cos phi क्या है? What is cos phi? Cos of 90 0, मतलब power consumption will be 0. अरे cos phi power factor क्या है? Cos of pi by 2, which will be 0. So power will be 0. मतलब power consumption by pure inductor will be 0. So what is our conclusion over here? मतलब whenever we are giving AC supply to a pure inductor, it will not consume any power. मतलब it will not consume any power. ठीक है? So that is all about AC through RL circuit. Next is AC through pure capacitor. AC through pure capacitor. There is a capacitor of capacitance C and AC supply is given to the pure capacitor. The instantaneous equation of AC supply is Vm sin omega t. Right? So we will derive this expression of current. Then only we can compare between voltage and current. Then we can find out phase difference, power factor and power consumption. So now tell me one thing, what is capacitor? Capacitor is a energy storing device which store electrostatic energy or which will store electric charge in terms of electric field. But what is capacitance? Capacitance is a property of a capacitor which opposes sudden change in voltage. Which opposes sudden change in voltage. And what is the voltage across the capacitor? The voltage across capacitor is 1 by C integration of I dt. Now you can ask, sir, how it is coming? Very easy. See, अगर एक कैपेसिटर है, मान लो कि कैपेसिटेंस C है, ठीक है, you know the principle of capacitor, Q is proportional to V, so Q is equal to CV. So दोनों साइड डिफरेंशिएट करो, मतलब dq by dt, you differentiate both the side with respect to time, मतलब d by dt of Q, so यहाँ पे भी डिफरेंशिएट करो d by dt of CV. dq by dt क्या है? करंट I, so C बाहर ले आओ, so it will be dv upon C into dv upon dt. Then you cross multiply, so dv will be 1 by C I into dt. अरे cross multiply कर दो. Then what is V? V will be integration of this one, मतलब 1 by C तो constant, मतलब voltage across the, you can say it is VC, V suffix C, अरे V suffix C, ठीक है. So voltage across the capacitor is 1 by C integration of I dt. मतलब here, just a minute. मतलब here, let AC, the current is given to a capacitor. What about its voltage? Voltage is VC 1 by C integration of I dt. Again, as per the energy conservation, ये जो voltage कैसे मिल रहा है? From the supply side only. As per the energy conservation, we can say VC is equal to V. VC क्या है? 1 by C integration of I dt. V क्या है? Vm sin omega t. Then from this expression, we can find out current. अब ये काम करते, क्रॉस मल्टीप्लाई कर दो, मतलब इंटीग्रेशन ऑफ I dt will be C into Vm sin omega t. Now you can do one thing, you differentiate LHS and RHS. So differentiation integration will be cancelled. अरे समझ में आ रहा है कि नहीं? You differentiate LHS and RHS. LHS को differentiate करोगे तो then क्या मिलेगा? Only current मिलेगा. Differentiation integration will cancel. But now differentiation of this one C into Vm sin omega t. इसका differentiation क्या होगा? C तो constant, Vm constant, sin omega t का differentiation क्या है? Cos omega t into omega. मतलब करंट क्या मिलेगा बोलो? C Vm omega into cos omega t. That is the expression of current. So now the point is, you have given voltage in sine form and current we are getting in terms of cos format. मतलब V is Vm sin omega t, I is omega c Vm cos omega t. So for easy understanding, we can convert cos function to sine function. Then only we can easily compare. मतलब I can write down here, it is omega c Vm. तो cos omega t को convert कर दो in terms of sine. cos ओमेगा टी क्या होता है? साइन ओमेगा टी प्लस 90 डिग्री और साइन ओमेगा टी प्लस पाई बाई 2. Okay, so now I can write down, let this one is Im. So I is equal to Im into sin omega t plus पाई बाई 2. So मतलब Im क्या है इधर? Im is omega c Vm. So I can write down Vm by, so this one I can write down Vm by 1 by omega c. और Vm by 1 by omega c. मतलब voltage upon opposition is current. According to Ohm's law, current through any electrical element, if it is AC, that current is voltage upon opposition. Here opposition is what? XC, capacitive reactance. मतलब XC क्या है इधर? 1 by omega c, मतलब 1 by 2 pi FC. XC क्या है? capacitive reactance. What is the unit of XC? Ohm. मतलब XC is the capacitive reactance, which is a opposing property of the capacitor which opposes the flow of current. Again I repeat, capacitive reactance is the opposing property of a capacitor which opposes the flow of current. I think it is clear. So now the point is, you have given current voltage as Vm sin omega t, current you are getting Im sin omega t plus 90. What is the phase of voltage? Omega t. What is the angle of voltage? Omega t. Here what is the phase of current? Omega t plus pi by 2. What is the phase difference? Pi by 2. मतलब phase difference symbol क्या है? phi. Phi is pi by 2. मतलब power factor क्या होगा? Power factor cos phi, it will be 0. So power का formula क्या है? क्या मैंने बोला था? AC में power is VI cos phi. Cos of 0 what? 0. Sorry, cos of 90 is 0. अरे since power factor is 0, what is power? Power will be 0. मतलब pure capacitor circuit will not consume any power. मतलब pure capacitor does not consume any power. मतलब what is your conclusion? If AC supply is given to pure capacitor, it will not consume any power. ठीक है? I hope it is clear. Now another point you might have asked, sir, is it leading circuit or lagging circuit? See, पहले voltage था Vm sin omega t, then current is Im sin omega t plus 90 degree. So to know whether it is leading or lagging circuit, then we can go for the phasor diagram or waveform. So पहले waveform देखो, ये वोल्टेज का वेवफॉर्म है Vm sin omega t. देन करंट का एक्सप्रेशन क्या है? ओमेगा टी प्लस पाई बाई 2. मतलब बिफोर 90 डिग्री करंट स्टार्टेड. एक्चुअली इट इज ए कंटिन्यूअस साइकिल. ठीक है. सो ये करंट Im sin omega t plus pi by 2. If I take 0 is a origin or this point as origin. ठीक है. So मतलब current lead, so I can say here current lead pi by 2 to voltage. current lead हो रहा है. So और एक मेथड है, मैं जो शॉर्टकट बोला था फेजर डायग्राम मेथड. You take current, always you take current as your reference parameter which will be in x-axis. Then you move clockwise. So first you will face current, then after 90 degree you will face voltage. मतलब it is your voltage. ये एंगल क्या है? 90 degree और pi by 2. मतलब here current lead voltage to 90 degree. यूजुअली स्टूडेंट मिस्टेक करते हैं, लिख लेते हैं वोल्टेज लीड. No, current lead or voltage lag. You can say voltage lag or current lead, but you cannot say both the things at a time. That's it. You take current as your reference parameter. If current is leading, that is leading circuit. If current is lagging, that is lagging circuit. Clear? ये हो गया AC through capacitor. See, और एक concept देखो, make a comparison. If AC is given to a resistor, what is the angle difference? 0. If AC is given to pure resistor, what is the angle difference between voltage and current? 0. Or you can say if there is a resistor, मान लो कि voltage across the resistor is VR and VR is AC and current is I. The angle between VR and I is 0 degree. Similarly, if you have an inductor, if there is a AC current is flowing through inductor, voltage across the inductor is VL. So the angle between VL and I is 90 degree. मतलब angle is 90 degree. अरे जैसे मैंने बोला था AC supply, मैंने क्या बोला था? If AC supply is given to pure inductor, what is the angle between voltage and current? 90 degree. As per the energy conservation, that voltage will be that induced voltage will be developed across the inductor due to the supply voltage, na? According to Lenz's law. So मतलब if AC current is given to a pure inductor, the angle between voltage and current is 90 degree. So diagram क्या होगा? ये होगा current, ये क्या है? voltage VL, angle is 90 degree. इसमें क्या होगा? ये अगर करंट है, ये वोल्टेज, the angle between voltage and current is 0 degree. ठीक है. Similarly, if AC is given to a pure capacitor, if AC current is flowing through a capacitor, the voltage across the capacitor and current is again 90 degrees. So phi is 90 degree, but it was lagging. Here it is leading. मतलब current lead, and this one is current, this one is voltage. एक overall idea आ गया. मतलब I have taken current as my reference parameter, which will be in x-axis. VR is in phase with current. मतलब phase difference is 0. In second case, I have taken current as my reference parameter, which will be in x-axis, and voltage makes 90 degree with respect to current. But here current lags. Current lags voltage, which is an angle of 90 degree. In third case, if AC is given to a capacitor, I have taken current as my reference parameter in x-axis. So here it will be VC, voltage across the capacitor. In this case, we can say current lead 90 degree to voltage. So ये point बहुत important है, because now I'll derive if AC supply is given to RL circuit, what will happen? If AC supply is given to RC circuit, what will happen? Then if AC supply is given to RLC series circuit, then what will happen? So to understand that concept, you need to know the three things: pure resistor, pure inductor, pure capacitor. Now I'll merge. If AC is given to RL circuit, AC is given to RL circuit, what about the angle between voltage and current? In between 0 to 90. Then if AC is given to R and C, what is the angle difference in between 0 to 90 degree? We'll derive this expression of impedance. Okay, और एक चीज याद रखो, अगर रेजिस्टर है, मान लो कि करंट इज I, रेजिस्टेंस इज R, what is the voltage across the resistor? I into R. अगर AC current is given. Similarly, if there is an inductor, current is I, inductance is L. Tell me what is the voltage? What is the voltage? वोल्टेज क्या है? एक चीज याद रखो, अकॉर्डिंग टू ओम्स लॉ, वोल्टेज इज करंट इनटू अपोजिशन ऑफर्ड बाय द सर्किट. व्हाट इज द अपोजिशन ऑफर्ड बाय द सर्किट? एक्सएल. मतलब वोल्टेज इज आई इनटू एक्सएल, और एक्सएल का यूनिट ओम है, आर का यूनिट ओम है. मतलब हियर V is IR, but here VL is I into XL. Do not write VL is I into L. L is inductance, XL is opposing property, which is called inductive reactance. Similarly, if you have a capacitor of capacitance C and AC current is given, so what is the voltage across capacitor? I into XC. The opposing property of capacitor is XC, capacitive reactance, that will oppose the flow of current. Opposition, XL opposes the flow of current. Here XC opposes the flow of current. Here R opposes the flow of current. So that thing also you need to know. So next is AC through RL circuit. देखो बहुत easy है. We take a RL circuit, resistance R, inductance L. So R and L both are in series, and AC supply is given, that voltage is V. So we will find out the expression of current and expression of impedance, expression of power factor and expression of power. See, let from that supply AC current is flowing. Matlab here current is I. Since it is series circuit, current through R and L will be same. Current through R, current through L will be same. So now tell me, if AC current is given to pure resistor, what is the voltage? VR, VR क्या होगा? I into R. AC current is given to pure inductor, what is the voltage? VL, VL will be I into XL. याद रखो I into XL. Just now I have told. ठीक है? So now we'll find out the net opposition. See, one thing you remember, you cannot say V is equal to VR plus VL. ये algebraic sum नहीं है, ये DC नहीं है, AC. AC मतलब phasor sum, vector sum of VL and VL, VR and VL will be V. मतलब V vector will be VR vector plus VL vector. Do not say V is equal to VR plus VL. अगर ये DC होता then you would have said, but it is AC. Understood? So V is equal to V vector is VR vector plus VL vector. So now we'll derive this expression of impedance. So what I have told, you have to draw the phasor diagram. I have taken current as my reference parameter in x-axis. AC current is given to resistor. The voltage will be VR. What is the angle between I and VR? 0. So matlab I and VR is 0. Dekho, I is and VR both are in same phase. Again same AC current is flowing through L. What is the angle between I and VL? 90 degree. मतलब ये I ये क्या है? VL. It will be 90 degree. So for better understanding, you go for the parallel shifting of vector. So you can shift this vector in that place. For easy understanding, yes or no? Parallel shifting class 11 physics. You can shift a vector or you can change the position of vector keeping the magnitude as constant and there will be no change in direction. That is called parallel shifting. Once you shift that vector, so you eliminate this one. So there are two vectors, both are in perpendicular. So what is the resultant? This one is resultant. Resultant is V. Matlab here V vector is VR vector plus VL vector. So the mod of V will be VR square plus VL square under root. Okay. So now our objective is to find out the angle between voltage and current. The supply voltage and supply current. What is the angle? Angle is phi. See, phi lies in between 0 to 90 degree. Since it is RL circuit. And it is leading or lagging. देखो current lags मतलब current lags angle phi to voltage. देखो lag हो रहा है ना phi. Okay, clear? Then I can write down in place of VR it is IR. In place of VL it is I into XL. ठीक है? And in place of V is supply voltage क्या है? Current into total opposition. That total opposition is called impedance. क्या है? Impedance. That unit is ohm. अरे इंडिविजुअल ऑपोजिशन ये ऑपोजिशन आर, यहाँ पे ऑपोजिशन क्या है एक्सएल, टोटल ऑपोजिशन क्या है जेड. सो अगेन अकॉर्डिंग टू ओम्स लॉ वोल्टेज इज करंट इनटू टोटल ऑपोजिशन ऑफ द सर्किट. सो वी इज इक्वल टू आई इनटू जेड. ठीक है. सो if I observe this triangle, in this triangle it is IR in x axis and y axis I into XL and here I into Z and this angle is phi. I will be cancelled. So matlab we will be getting this one is R and this one is XL and this one is Z. This triangle is called impedance triangle. Which triangle? Impedance triangle. This triangle is called impedance triangle. And here tell me what is power factor cos phi? Power factor cos phi, it is a right angle triangle. Cos phi is B by H. B matlab R, H matlab Z. So cos phi का formula क्या हो गया? R upon Z. ठीक है. And what is the right angle triangle? You use Pythagoras theorem. So Z will be R square plus XL square under root. ये हो गया expression of impedance. Now can you tell me here what is the expression of power? Power will be VI cos phi. Here cos phi is not 0 since it is a RL circuit. That is the angle. That angle lies between 0 to 90 degree. I hope it is clear. Okay, now AC through RC circuit. AC through RC circuit. So resistance R and C both are in series, and supply is your AC, V, resistance R and capacitance C. AC current is flowing through resistor. What is the voltage across resistor? It will be I into R. Yes or no? Same AC current is flowing through capacitors in series circuit. In series connection, current will be same. And what is the voltage across capacitor? I into XC, because capacitance का opposition क्या है? XC, capacitive reactance. So voltage VC is I into XC. Here VR is I into R. ठीक है? Same concept will apply. The phasor sum or vector sum of these two voltages VR and VC will be V. You cannot say algebraic sum. You have to say phasor sum or vector sum. ठीक है? So now coming to the phasor diagram. So to find out impedance, we can go for phasor diagram. जैसे मैंने बोला था, we have to take current as your reference parameter, which will be in x-axis. देखो मैंने x-axis में लिया. AC current is given to a resistor. What is the voltage? VR. The angle between voltage and current is 0 degree. ठीक है, ठीक है. Now same AC current is flowing through capacitor, and the angle between this voltage and current is 90 degree. But leading or lagging? Leading circuit. मतलब here it will be VC. Current lead 90 degree. Current lead 90 degree. But मैंने क्या बोला था? You can go for parallel shifting. You can shift that vector from this position to this position, keeping the magnitude and direction as same constant. Then you can eliminate this one. ठीक है, मतलब we are getting two vector. One is VR, second is VC. Both are in perpendicular to each other. This one will be a resultant. That resultant is V. And what is your final angle between voltage and current? The angle is this one, phi. So final angle क्या है? Leading or lagging? Leading. So मतलब here current lead phi to voltage V, and the phi lies between 0 to 90 degree. Yes or no? Clear? So we can write down the modulus of V is VR square plus VC square under root. Pythagoras theorem apply करो. And VR क्या है? I into R. VC क्या है? I into XC. See, VR is I into R, VC is I into XC. V क्या है? I into Z. मतलब total opposition. Total opposition is called impedance. क्या है? Impedance. Net opposition offered by the circuit. So total voltage क्या है? Total current into total opposition according to Ohm's law. Current into impedance. ठीक है? So if I take this triangle, only this triangle. So this one is your IR, and y-axis it is I into XC, and in Z, this one is your I into Z, and this angle is phi. So I will be cancelled. So what is left? This one is R, this one is XC, and this one is Z, and this one is angle. So as per the Pythagoras theorem, impedance क्या है? R square plus X square under root. And cos phi क्या है? Cos phi power factor. Right angle triangle cos phi मतलब b by h, so it will be again r by z. मतलब पावर फैक्टर का फॉर्मूला हमेशा रेजिस्टेंस अपॉन इम्पीडेंस. ये RL सर्किट हो सकता है, RC सर्किट हो सकता है, और इट मे बी RLC सीरीज सर्किट. ठीक है. सो पावर कंजप्शन कितना होगा? 0 होगा? 0 नहीं होगा, क्योंकि cos phi has some value, so power will be VI cos phi. मतलब that RC circuit will consume some power, just say RL circuit was consuming some power. But if it is pure inductor, power will be 0. If it is pure capacitor, power will be 0. If it is combination of R and C or R and L, matlab that coil or that circuit will consume some power. Okay, last one is AC through RLC series circuit. AC through RLC series circuit. So we have taken a coil having three parameter R, L and C. R, L, C all are in series, and AC supply is given. That voltage is V and current is I. Since it is series circuit, current through each element will be same. मतलब current through R, current through L, current through C will be same. And voltage across the resistor is VR, which will be I into R. Voltage across the inductor is VL, which is I into XL. and voltage across the capacitor is Vc, that is I into Xc. To find out the net opposition or impedance of the circuit, or to find out the power factor of the circuit, or to find out the power consumption by the circuit, so we can go for phasor diagram. जैसे मैंने बोला था, you have to take current as your reference parameter which will be taken in x-axis. See, AC current is given to resistor. The angle between VR and I is 0. So the angle between VR and I is 0. Again, same current is flowing through VL. So the angle between I and VL is 90 degree, leading or lagging? Lagging 90 degree. मतलब here it will be क्या है? Here it will be VL. ठीक है? Again, same current is flowing through. The angle between voltage and current is 90 degree. Current lags 90 degree. And in third case, same current is flowing through C, and the angle between I and VC is again 90 degree, but current lead. मतलब यहाँ पे current मतलब यहाँ पे voltage होगा, ये VC है. So now there are three vectors VL, VC and VR. How do you find out the resultant vector? So for that you do one thing, इसको parallel shift कर दो. VL को मैंने parallel shift किया, इसको eliminate कर दो, ठीक है. VC को parallel shift कर दो. पैरेलल शिफ्टिंग तो पता होगा आप लोग को, बहुत बार बोल चुका हूँ. पैरेलल शिफ्टिंग मतलब यू कैन चेंज द पोजीशन ऑफ अ वेक्टर कीपिंग द मैग्नीट्यूड एंड डायरेक्शन विल रिमेन सेम. मतलब मैग्नीट्यूड चेंज नहीं होगा, डायरेक्शन चेंज नहीं होगा, बट यू कैन शिफ्ट ए वेक्टर फ्रॉम वन लोकेशन टू अदर लोकेशन. दैट इज कॉल्ड पैरेलल शिफ्टिंग. ठीक है. नाउ देयर आर थ्री वेक्टर. How do I find out resultant vector? देखो, there are two vector are in opposite direction, but we do not know the magnitude. अगर magnitude same होगा, then it would have say कि both will be cancelled. Actually, there are three vector VR, VL, VC, but VL and VC both are in opposite direction. Magnitude same नहीं है. We do not know. That magnitude depends on what? The value of L and C. अरे VL क्या है? I into XL. VC क्या है? I into XC. मतलब करंट तो सेम है, मतलब जिसमें XL ज्यादा है होगा. अगर XL is more than XC, then of course VL will be more than VC. So that's why we can take different case. First case we can take if XL is more than XC. If XL is more than XC, मतलब VL will be more than VC. अगर VL is more than VC, what is the resultant? What is the resultant? Resultant will be VL minus VC. So now you can get two vector, one is VR, other is VL minus VC. This one will be a resultant V. Yes or no? And ये तुम्हारा एंगल, फाइनल एंगल, ये फाइनल वोल्टेज है, फाइनल करंट, ये हो गया एंगल. ठीक है. Or else you can write down here I into XL minus I into XC. If I take I as common, it will be I into XL minus XC. And here I can write I into R, current into resistance. But in place of V, I can write down I into Z, total opposition of the circuit, which is called impedance. Unit is ohm. Okay. So if I take this diagram, so this one is R and this one is XL minus XC and this one is Z. ये हो गया एंगल. So मतलब एंगल क्या होगा? The angle difference between R and Z. So impedance का एक्सप्रेशन क्या होगा? राइट एंगल ट्रायंगल Z क्या है? R square plus XL minus XC whole square under root. एंड पावर फैक्टर क्या है? cos phi. cos phi क्या होता है? B upon H मतलब R by Z. Since there is an angle and you can get some power will be VI cos phi. So now one thing you tell me, the circuit is leading or lagging circuit. Since inductive reactance is dominating over capacitive reactance, यहाँ पे mention किया ना, if XL is XC मतलब entire circuit will act as RL circuit. L parameter will dominate over C parameter. The net circuit will act as a RL circuit. If it is RL circuit, it is leading or lagging circuit? It is lagging circuit. मतलब current lags, देखो current lags some angle phi to voltage V. Is it clear? And case 2 I'm not going to do, you can do it. Case 2 same है. अगर XC more than XL, if XC is more than XL, then VC will be more than VL. ये जो डायग्राम ना, ये नीचे आ जाएगा, ऐसे हो जाएगा. मतलब VC is more than VL. ठीक है. So resultant is VC minus VL. तो ये हो जाएगा आपका Z. V is I into Z. Angle this one is angle. अरे same thing. बट मैग्नीट्यूड में ज्यादा फर्क नहीं पड़ेगा, क्योंकि ये क्या हो जाएगा, एक्सी माइनस एक्सएल। देखो नेगेटिव स्क्वायर इज पॉजिटिव, पॉजिटिव स्क्वायर इज पॉजिटिव, दैट्स व्हाई ये आरएल सर्किट लीडिंग सर्किट या लैगिंग सर्किट, उससे इंपिडेंस का कोई मतलब नहीं है, मतलब इंपिडेंस मैग्नीट्यूड ऑफ इंपिडेंस विल बी सेम, ठीक है, मैग्नीट्यूड ऑफ इंपिडेंस विल बी सेम, क्योंकि एक्सएल माइनस एक्स विल बी माइनस एक्सी माइनस एक्सएल होल स्क्वायर, दोनों का तो स्क्वायर होना। डिफरेंस क्या है, हाँ डिफरेंस मतलब वन इज लैगिंग सर्किट अदर इज लीडिंग सर्किट, मतलब ये आरएल, अगर सेकंड केस को हम लोग कंसीडर करेंगे, इफ एक्सी इज मोर देन एक्सएल इट विल बी लीडिंग सर्किट, if it is first case it will be lagging circuit, okay, since there is some angle, power is vi cos phi, okay, so that is all about the concept of RLC series circuit. So look at the question, एक example है pure capacitor, so look at the question, a 318 microfarad capacitor is connected to 230 volt. Look at the question, a 318 microfarad capacitor is connected to 230 volt 50 hertz AC supply. Calculate capacitive reactance, RMS current and equation of instantaneous equation of voltage and current. It is very easy. See, there is a capacitor, pure capacitor, you have given voltage, that voltage is 230 volt and frequency is 50 hertz, okay, and capacitance value is given 318 microfarad, okay. So first bit क्या है, capacitive reactance. What is the formula of capacitive reactance? 1 by 2 pi fc. See 2 pi तो वैल्यू पता है, 2 pi कितना है 3.141, फ्रीक्वेंसी कितना है 50, कैपेसिटेंस वैल्यू इज गिवन 318 into 10 to the power minus 6. So put the value and get the answer, ठीक है, you can do it. So coming to RMS current, to find out RMS current you need to know one thing, ये जो वोल्टेज, the voltage which will be given in the question, that is RMS voltage, मतलब RMS voltage is given 230 volt, clear. If RMS voltage is given, so you can find out RMS current is RMS voltage upon opposition. अरे RMS current क्या है, IRMS क्या है, VRMS voltage upon opposition, that is one method. और भी एक मेथड है, मतलब अगर ठीक है, मतलब RMS IRMS इज VRMS अपन XC, ठीक है, VRMS कितना है 230, XC ऑलरेडी यू गॉट फ्रॉम हियर, यू पुट द वैल्यू एंड गेट द आंसर. सो RMS करंट मिल गया. इक्वेशन ऑफ वोल्टेज एंड करंट क्या है, इंस्टेंटेनियस इक्वेशन क्या था, Vm sin ओमेगा t, करंट इक्वेशन क्या था, Im sin, टेल मी, Im sin ओमेगा t plus pi by 2. It is a pure capacitor. The angle between voltage and current is 90 degree. Then we do not know Vm and Im. So to find out Vm and Im, you know RMS voltage is maximum voltage by root 2. So इससे क्या मिल जाएगा, Vm मिल जाएगा, because VRMS पता है, क्रॉस मल्टीप्लाई करो आंसर मिल जाएगा. Then Im क्या है, Im क्या है, IRMS अपॉन, सॉरी IRMS क्या है, I मैक्सिमम अपॉन रूट 2. तो इससे तुम्हें Im मिल जाएगा क्योंकि IRMS पता है, ठीक है. देन ये दोनों का वैल्यू Vm और Im का वैल्यू यहाँ पे डाल दो, देन आंसर मिल जाएगा. एंड ओमेगा इधर क्या होगा, ओमेगा इज 2 पाई f, ठीक है, जो भी आंसर होगा यू ट्राई इट, ठीक है. मैं सिर्फ कॉन्सेप्ट बोल रहा हूँ, आई एम नॉट हियर टू वेस्ट टाइम, अननेसेसरी टाइम वेस्ट होगा क्योंकि क्वेश्चन एग्जाम में डिफरेंट वैल्यू होगा. यू नीड टू अंडरस्टैंड द कॉन्सेप्ट, दैट इज मोस्ट इंपोर्टेंट, ठीक है. और एक क्वेश्चन करेंगे बेस्ड ऑन RL सीरीज सर्किट. क्वेश्चन क्या है, ए कॉइल ऑफ रेजिस्टेंस 10 ohm and inductance, let it be 2 millihenry in series, in coil is given by a AC supply of 230 volt 50 hertz. ठीक है, find, there are different parameter you have to find out. First is impedance, second is current, third one is power factor, and fourth one is power. Very easy. R and L both are in series. R कितना है 10, L कितना है 2 मिली हेनरी, मतलब 2 into 10 to the power minus 3 Henry. And AC supply is given, voltage is given 230 volt, and frequency is given 50 hertz. So first point you find out XL. XL क्या है 2 pi FL. अरे XL क्या है 2 pi FL, L का वैल्यू यहाँ पे डाल दो, XL मिल जाएगा. So फर्स्ट पॉइंट क्या है Z. Z का फॉर्मूला क्या है RL सर्किट में, अभी भी बोला था R स्क्वायर प्लस XL स्क्वायर अंडर रूट. R is given 10 ohm. XL already you got from here, you put here and get the answer. You do it. सेकेंड Z मिल गया. सेकेंड क्या है करंट. जैसे हमने बोला था टोटल करंट क्या है, टोटल वोल्टेज अपन टोटल अपोजिशन. अरे करंट क्या है वोल्टेज अपन अपोजिशन, मतलब करंट इज V अपन Z. वोल्टेज पता है कितना है 230, और इम्पीडेंस का वैल्यू तो मिला, इधर से डाल दो आंसर मिल जाएगा. ठीक है. थर्ड क्या है पावर फैक्टर. पावर फैक्टर क्या होता है cos phi. cos phi का फॉर्मूला क्या है R by Z. तो रेजिस्टेंस पता है कितना है 10, इम्पीडेंस ऑलरेडी यू गॉट फ्रॉम हियर, यहाँ पे डाल दो आंसर मिल जाएगा. एंड फाइनल बिट क्या है पावर. पावर क्या है VI cos phi. वोल्टेज मतलब ये RMS वोल्टेज, करंट इज RMS करंट, ये जो करंट है ना RMS करंट, एंड वोल्टेज इज RMS वोल्टेज, मतलब दोनों का वैल्यू यहाँ पे डाल दो, cos phi का वैल्यू डाल दो, देन आंसर मिल जाएगा. So that is all about RL series circuit. Next question is based on RC series circuit. Next question, मतलब a resistor, क्वेश्चन क्या है, a resistor of resistance 10 ohm is in series with a capacitor of capacitance 50 microfarad. Of capacitance let it be 100 microfarad, is connected to a AC supply of 230 volt 50 hertz. So we'll have to find out impedance, second bit current, third bit power factor, fourth bit phase angle, fifth bit power consumed by the circuit. Again I repeat, impedance, current, power factor, phase angle and power. So ये question क्या है, it is a which type of circuit, RC circuit. Resistance value is given 10 ohm, capacitance value is given 100 microfarad, मतलब 100 into 10 to the power minus 6. ठीक है. एंड AC supply is given, voltage 230 volt, frequency is 50 hertz. यहाँ पे current, you have to find out current. First we'll find out impedance. So to find out impedance, you know impedance का formula क्या है R square plus XC square under root, but you do not know XC, तो इसलिए तुम्हें XC चाहिए. XC क्या है 1 by 2 pi FC, कैपेसिटिव रिएक्टेंस का फॉर्मूला मैंने बोला था. XC is 1 by 2 pi FC. 2 pi F तो पता है, pi का वैल्यू 3.141, frequency is 50, and C is 100 into 10 to the power minus 6. Just put the value and get the answer. जो आंसर मिलेगा यहाँ पे डाल दो, क्या मिल जाएगा Z मिल जाएगा, क्योंकि R is given 10, जो भी XC मिलेगा यहाँ पे डाल दो Z मिल जाएगा. ठीक है. सेकेंड बिट क्या है करंट. करंट क्या है टोटल वोल्टेज अपन टोटल अपोजिशन. टोटल अपोजिशन क्या है इम्पीडेंस, so मतलब V by Z. तो Z तो यहाँ से मिला, V is 230, here V is 230, so 230 by Z, जो भी Z मिला यहाँ पे डाल दो आंसर मिल जाएगा. ठीक है. मैं क्वेश्चन मार्क दे रहा हूँ, you do it and write in comment box if you want. I'm not forcing you. ठीक है. if you are really getting something from the video, then you can subscribe my channel and you can mention comment. I'm not forcing you. ठीक है. थर्ड बिट क्या है पावर फैक्टर. पावर फैक्टर क्या है cos phi. cos phi क्या होता है R upon Z. ठीक है. सो रेजिस्टेंस कितना है 10, Z is already you got, यहाँ पे वैल्यू डाल दो आंसर मिल जाएगा. क्वेश्चन मार्क फिर से दे रहा हूँ. एंड फोर्थ क्या है फाई। अगर cos फाई मिल जाएगा, फाई क्या है cos इनवर्स, जो भी वैल्यू मिलेगा cos इनवर्स ऑफ दिस वैल्यू विल बी फाई। एंड लास्ट बिट पावर, पावर क्या है वी आई cos फाई। एंड कभी कभार आ सकता है क्वेश्चन, इट इज लीडिंग और लैगिंग सर्किट। ऑफ कोर्स इट इज लीडिंग सर्किट सिंस इट इज आरसी सर्किट। Now coming to last question, and last question is based on RLC series circuit, which is very important. So actually I am getting tired now. It is 2:30 p.m. and I am making video. So anyhow, last question, RLC series circuit. क्या क्वेश्चन आ सकता है? A coil of resistance 10 ohm and inductance, let it be 30 millihenry, is connected series with a capacitor, is connected series with a capacitor of capacitance 50 microfarad। जो भी है मैं वैल्यू आर्बिट्रली दे रहा हूँ। capacitance 50 microfarad is given by supply, AC supply of 230 volt, 50 hertz। ठीक है, so we'll have to find first bit impedance, second bit current, third bit power factor, fourth bit phase angle, and fifth bit power consumed by the circuit। RLC series circuit, resistance is given 10, inductance is given 30 millihenry, मतलब 30 into 10 to the power minus 3 henry। capacitance is 50 microfarad, 50 into 10 to the power minus 6 farad। current is I here। ठीक है, so we'll find out impedance। first bit impedance का formula क्या है? r square plus xl minus xc whole square, or you can mention r square plus xc minus xl whole square, both will be same, under root। ठीक है, so you know r but you do not know xl, इसलिए पहले xl निकालो। xl क्या है? 2 pi fl। l is given, 2 pi f is constant, then you can get xl। Similarly xc निकालो, xc क्या है? 1 by 2 pi fc। everything is given, c is given, 2 pi f is constant, so you can get xc। so now you can put the value of xl and xc in this equation, then you can get the value of z because r is given। ठीक है, सेकेंड बिट क्या है? करंट। करंट क्या है? वोल्टेज अपॉन टोटल अपोजिशन। व्हाट इज द टोटल अपोजिशन? जेड। सो मतलब करंट इज वोल्टेज अपॉन इम्पिडेंस। इम्पिडेंस तो यहाँ से मिल गया, वोल्टेज इज गिवन, वोल्टेज इज 230 वोल्ट। ठीक है, सो मतलब 230 बाई दिस वैल्यू विल बी गेटिंग सम आंसर। ठीक है, ये तुम खुद करो, मैं कॉन्सेप्ट बोल रहा हूँ, सिर्फ कॉन्सेप्ट बोल रहा हूँ। कॉन्सेप्ट इज इम्पोर्टेंट, न्यूमेरिकल प्रैक्टिस करना भी इम्पोर्टेंट है। इफ यू डू नॉट अंडरस्टैंड द कॉन्सेप्ट, इफ यू डू नॉट नो हाउ टू अप्लाई दैट फॉर्मूला, देन जितना भी न्यूमेरिकल करो कुछ फायदा नहीं होगा। थर्ड पॉइंट क्या है? पावर फैक्टर। पावर फैक्टर क्या है? cos phi, which is r by z। r you know 10, z already you got from here, then you can get some answer। fourth bit phi, power phase angle। phase angle क्या होता है? cos inverse of that value। लास्ट बिट पावर क्या होता है? वी आई cos phi। v क्या है? 230। करंट क्या है? जो भी करंट मिला, आरएमएस करंट एंड आरएमएस वोल्टेज, cos phi तो मिल गया, देन आंसर मिल जाएगा। ओके, सो दैट इज ऑल अबाउट entire AC circuit। What I have explained today: AC through R, AC through L, AC through C, AC through RL, AC through RC, AC through RLC, and we got expression of impedance like in RL circuit R square plus XL square under root, RC circuit R square plus X square under root, in RLC circuit R square plus XL minus XC whole square under root, and we knew that the concept of power factor and power consumption by the different circuit। Hope you guys understood what I've explained today। Okay, so thank you so much for watching my video। Thank you once again, thank you।